Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. And make sure to stick to the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so we are given that 5 to the power of x equals 7. So now we want to find the value of 7 to the power of x. So the first thing to do is find the value of x. So we have 5 to the power of x is equal to 7. Now to find the value of x here, I'm first going to take the log on both sides. So now I have log 5 to the power of x is equal to log 7. Now an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front. So it's going to equal b times log a. So in this case, I can move x to the front. So now I have x times log 5 is equal to log 7. Now if I divide both sides by log 5, these two cancel out, and now I'm left with x is equal to log 7 over log 5. Now, log 7, this is equal to 0.8451. And log 5, this is equal to 0.6990. So now if I substitute these values into our expression here, I get x is equal to 0.8451 over 0.6990. So now if I divide these two, I get x is equal to 1.2090. So this is my value for x. However, we want to find the value of 7 to the power of x. So if we know that x is equal to 1.2090, then 7 to the power of x is the same thing as 7 to the power of 1.2090. And this is equal to 10.5129. So 7 to the power of x is equal to 10.5129. So this is my answer. Alright, so I have 3 to the power of x plus 3 to the power of x is equal to 10. So I want to find the value of x here. So for my solution, first start with 3 to the power of x plus 3 to the power of x is equal to 10. Now, because I have 2 3 to the power of x's on my left-hand side, I'm simply going to factor out 3 to the power of x from my left-hand side. So now I have 3 to the power of x times 1 plus 1 is equal to 10. Now 1 plus 1, that's equal to 2. So now I have 3 to the power of x times 2 is equal to 10. Now, if I divide both sides by 2, these two cancel out. Now I'm left with 3 to the power of x is equal to 10 divided by 2, which is 5. So now I just got another equation, 3 to the power of x equals 5. So now to solve this, I'm going to first take the log on both sides. So now I have log 3 to the power of x is equal to log 5. Now, an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this would equal b times log a. And what's so important about this property is that right now, as you see, x here, this is an exponent. And it's really hard to solve for x right now the way it is because x is actually going to be a decimal. Because we know that 3 to the power of 1 is equal to 3, and 3 to the power of 2 is equal to 9. And 5, this is somewhere in between 3 and 9, meaning x is somewhere in between 1 and 2. However, we can't find that exact value the way it is right now. So now that if we move x to the front, now x will be a real term, and it's going to be much easier to solve for it. So I have log 3 to the power of x is equal to log 5. And now if I move x to the front, I get x times log 3 is equal to log 5. And now if I divide both sides by log 3, these two cancel out, and I'm left with x is equal to 0.699 over 0.477, which is equal to 1.464. So this is my answer. All right, so I have 8 to the power of 16 plus 8 to the power of 16. So for my solution, eight here, this is the same thing as 2 to the power of 3. So now, if I go ahead and substitute in 2 to the power of 3 for 8, I get 2 to the power of 3 to the power of 16 plus 2 to the power of 3 to the power of 16. So now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. So these two simply just multiply. So in this case, I have 2 to the power of 3 to the power of 16. So we can think of a as 2, m as 3, and n as 16. So this would be equal to a to the power of m times n. So 2 to the power of 3 times 16, and 3 times 16 is equal to 48. So now I have, 2 to the power of 48. So now I have 2 to the power of 48 plus 2 to the power of 48. So now from here, if I factor out 2 to the power of 48, I get 2 to the power of 48 times 1 plus 1, because 2 to the power of 48 divided by 2 to the power of 48 is 1. Now 1 plus 1, that's equal to 2. So now I have 2 to the power of 48 times 2. Now 2 here, this is the same thing as 2 to the power of 1. And now if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So 2 to the power of 48 times 2 to the power of 1, this is equal to 2 to the power of 48 plus 1, which is equal to 2 to the power of 49. So this is my answer. Back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 3 to the power of x equals 243, and our goal is to find the value of x. So whenever we're solving exponential equations like this, we always want to make our bases here, which in this case are 3 and 243, we want to make them the same. Because let's say we have a to the power of x equals a to the power of c, right? Because our bases are same in this case, we know that our exponents are the same as well. So we could just set them equal to each other. We know that x is equal to c. So in this case, if we make our bases the same, then we know that our exponents are the same as well, and then we can find the value of x easily. So we have 3 to the power of x equals 243. So how would we convert one of these numbers to make the other one the same as this one? Well, let's do 243. 243 is equal to 3 to the power of what? 3 to the power of 5. 243 is equal to 3 to the power of 5. So what we're going to do is we're going to write 3 to the power of x equals 3 to the power of 5, because 243 is 3 to the power of 5. Now, our bases are the same, so we know that our exponents here, x and 5, we know that these two are the same as well. So now we could simply make these two equal each other. So x equals 5. And this is our answer. So it's as simple as that. And we already know that 243 equals 3 to the power of 5, so we don't really need to do any of this. We already see that 3 to the power of 5 equals 243, so we already know that x equals 5. So that's another way.